Welcome back. This is Dr. Webb, and today we're going to be talking about the quotient rule. So this is in the text. This is taking place in section 3.2. One thing I want to say, at the beginning is often books, they group the quotient rule in with the product rule. I obviously am doing a little bit different, and that's because to me the quotient rule really is a combination of the product rule and the chain rule. Those two are the more fundamental rules. The quotient rule is kind of a secondary rule that comes out of that, and so that's how I'm going to present it to you guys. Focus on it. And if you don't like it, you can just go look in section 3.2, follow what the book does. Okay, so far these are all the main derivative rules we've done so far. Quotient rule is going to really round this out. Those are all the big derivative rules. If you have a constant, first one, we have a constant, you can always just pull the constant out. Derivative of a sum is the sum of the derivatives. We've talked a bunch about that. We've been doing a lot with the product rule. Derivative of f times g is f prime g plus f g prime. And then we've even done a good amount of work on the chain rule. So we're going to put these in action. Particularly, we're going to be using these two together to get the quotient rule. So our focus today is figuring out what's the derivative if we have f divided by g, right? Rather than f times g, what do we get when we do f divided by g? And so our first step towards this is we're going to think about, well, what if on the top for the numerator we just have 1? So we're just thinking about the derivative of 1 over g. Okay, and we're going to think about this. We've actually done quite a number of problems so far that essentially are this already. And so we're just going to keep going that way, and we're going to use the same trick we've always done, whereas if it's, 1 over something is the same thing as that thing to the minus 1 power. And so that's what we're going to do. We're going to be thinking about taking the derivative of g of x and then raising g of x to the minus 1 power. And so then when we're thinking about it that way, this is turning into a chain rule problem, right? Where g is our inside function. And so then what's the outside function here? F, that's just raising everything to the minus 1 power. Okay, g is g, and so then we can finish working out the chain rule. Derivative of g is just going to be the derivative of g, but what's the derivative of x to the minus 1? Well, this is a power rule problem now. Power comes down, and then take 1 away from minus 1 gives us minus 2. Right? And so now when we work this into the chain rule, so chain rule is derivative of g plugged into f prime g times g prime. And so what's that going to give us here? Well, we're going to have minus g to the minus 2 power times g prime. And let's make that look nice. There it is, minus g times g of x to the minus 2. So there's our inside. There's our derivative of the inside. And then the minus to the minus 2, that's the derivative of the outside. Okay. And then let's erase this. And so then often I want to clean it up to make it look nicer. At least some people think it's nicer. Since we've got the negative power right there, we're going to move that whole term into the denominator. right? So at the end of the day, if you're taking the derivative of 1 over g of x, it's going to be equal to minus g prime of x divided by g squared. Okay. So how can we use that now if we want to take the derivative of one function divided by another? Okay. Well, we're going to use the same idea as before. We're going to take the bottom function, move it up. And so we're going to rewrite this as f of x times g of x to the minus 1. Now this looks like a straight product rule problem. Right, so product rule, we've already got f and g going here, so I'm going to use u and v. So product rule says derivative of u times v, u prime v, plus vu prime. Okay, so u here is f, so u prime is f prime. On the other hand, v well, this is g of x all raised to the minus 1, and we just figured out what its derivative is. We'll call that v prime, and that is minus g prime of x times g of x to the minus 2. And so then when we're going to apply the product rule, and so u prime v is going to give me f prime of x times g of x to the minus 1. And then u times v prime, well, u is f of x, and then we have to multiply by that whole guy, so it's times minus g prime of x times g of x raised to the minus 2. And so it's a little bit ugly having this minus sign inside the parentheses, so we're going to move that minus sign out. Let's use the eraser. Take u out. It's going to turn this plus into a minus. And so that's what we get. So let's make it look nice and tidy. And that's what we had written before. And then we've got these negative powers here. So we might want to move these negative powers down below. And so we've got g of x to the first power here and g of x squared there. And if you notice, these two denominators, they're pretty similar, except this one has a squared to it. And so we can combine this into a single fraction by multiplying by g of x to this one, but if we multiply it down there, we also have to multiply it up here. And so when we put that all together, we're going to end up with, we have the g of x squared on the bottom, and then this g of x here comes from raising that to the second power. We got to multiply another g of x to the top and bottom, so that's what happened there. And then this term over here is minus f of x times g prime of x. And so this is how we're going to think of the quotient rule. So d dx of f over g is equal to f prime g minus f g prime all over g squared, right? And so if you notice, we've been thinking a lot about product rule in terms of you've got your f, your g, your f prime, and your g prime, and then the terms kind of come from the diagonals. And we still have the same sort of thing going on here, this first term still comes from that first diagonal here, but with the quotient rule, the one main difference is for the second diagonal, rather than having a plus, it's a minus sign. And so it's minus the other diagonal. So order here between f and g is really important because we want to make sure that it's the derivative of the bottom gets the minus sign, not the derivative of the top. There's a lot of kind of common mnemonics that people use. One that I've heard the most is that the quotient rule is high d low minus low d high over low squared. And so if you think about this, this is low is g of x, d high, so that's talking about the derivative of f. So low d high minus high d low. So d low is g prime, and then divided by low squared. Okay, so that's what the quotient rule is. Okay. So let's do one example, go through and see how this works. Now that we've got this done, we can just start plugging away. So what's our top function here? What's x plus 3? So let's call that f. Our bottom function is x squared minus 1. Okay, so now that we have this broken up, we can take the derivatives of these individually. So derivative of x plus 3, well, derivative of x is just 1, and then the plus 3 disappears, turns into 0, so f prime is really just 1. G prime, derivative of 2x of x squared, getting ahead of myself, is 2x, and then the minus 1 disappears. It's just a constant. Okay, so we have f, we have g, we have f prime, we have g prime. That's all we need. So remember, this is going to be, quotient rule is f prime g minus fg prime all over g squared. So we have f prime g is going to give us x squared minus 1 minus f g prime. Let's use the same color. Let's be consistent a little bit. So f times g prime, and then divide by g squared. So g is x squared minus 1, quantity squared. Okay. And so deep down, that's what the quotient rule is. Okay. Yep. So that's what I wrote there. So this is, we've got x squared minus 1. That's really coming from f prime is 1 times g minus f times g prime all over g squared. So the 1 there, that is f prime g minus f g prime all over g squared. And then if you wanted to go through and simplify this out, this is what you end up with at the end. Again, you don't have to do this. That's just purely for aesthetic reasons. If you need it simplified out or expanded out, that's how you can do it. Okay, so here's some practice problems that we'll go over on Wednesday. So the first one, very similar to the last one, was what's the derivative of x minus 1 over x plus 1? Very straightforward. For these last two, These are really, trying to get you to mix the quotient rule with the chain rule. So for the number 2, the second one, we've got this x plus 4 plugged into square root of x. So you're going to need to use the chain rule when you're taking the derivative of the bottom here. On the other hand, for number 3, we have a quotient plugged into the square root, right? And so how do you set that up with the chain rule? When you've got something, you got a quotient plugged into the square root, what's sort of the inside function there and what's the outside function? Okay, so I hope to see you all there.